Okay, in this problem, I'm going to ask you to provide a mechanism for the observed product. So this is the major product. So I'm asking for provide a mechanism for this and identify any possible minor products. Okay, so hit pause. I'm giving you, here's the reagent, here are the conditions, here's the product. Provide a mechanism for that, provide the identity of any minor products. Hit pause, take that away. Okay, so do you have a leaving group? And this is a substitution elimination. We're getting an elimination. We're making an alkene, so this must be some sort of elimination reaction. But what do you notice? You notice that the carbon skeleton changes. We go from a 4-membered ring to a 5-membered ring. So the carbon skeleton has changed. We haven't added any carbons. We have 1, 2, 3 plus 4 is 7 carbons on the left. 1, 2 plus 5 is 7 on the right. So this is a straight up elimination, but with a carbon skeleton change. And so the carbon skeleton changes. This should tell you that there's some sort of cation rearrangement. Okay, so how do we make a carbocation? Do you have a leaving group here? In fact, you don't. OH is not a leaving group. Water is a leaving group, however. And so, under acidic conditions, we can protonate the alcohol. Okay, so we have protonated or alkylated water, basically. And now, to make our cation, the water leaves. These are all reversible reactions. So there's the carbocation, and we also have water. And now here's the clever bit. We have a 4-membered ring, so you should remember from the first couple of chapters that 4-membered rings have significant ring strain to them. And so you can have an alkyl group migration under which we can expand the ring. So this carbon can move to the carbocation. Okay, so this bond, these 2 electrons and this carbon-carbon bond are moving to make a bond between this carbon and that carbon. If we number these, 1, 2, 3, 4, 5. Carbon 1, currently bonded to 4, will take its electrons and bond to carbon 5. If we take electrons away from carbon 4, that's going to leave a positive charge on carbon 4. So I'm going to erase some of my writing here. Okay, so this will give us 5-membered ring now. Let's do the numbering again. So 1, 2, 3, 4, 5. Carbon 5 has a methyl on it, and it's going to have a new bond to carbon 1. Carbon 4 loses the bond to carbon 1, and it has a methyl on it. So there's the intermediate carbocation. And again, this is an equilibrium, but which cation is more stable? Secondary cation with a 4-membered ring, or a tertiary cation with a 5-membered ring? Overwhelmingly, this equilibrium lies toward the 5-membered tertiary carbocation. And then how do we get to this alkene? The way you get to that alkene is to do an elimination. Water is the base, takes that proton, makes the pi bond. That gives us our major product. How about minor products? Well, okay, I'm going to go ahead and erase over here. You can go back and watch if you need to. So this is our intermediate carbocation. Water could add to the cation, and in a couple of steps we'd get a new alcohol. You have diastereomers there, you can have the methyl, cis, or trans. We could also eliminate there and make a different alkene, right? So we make a pi bond there, or we could eliminate here So those are 3 products you could get. You could also fail to rearrange. Remember, we had that cation in there originally. We can't make a pi bond here, but you could eliminate nope, sorry, put too many carbons in. So you could make an alkene there, or, man, that's it. That's really it. These are pretty much the other minor products you could get. Which of those are likely? Well, some would depend on the temperature, which I don't give you. But elimination, that's a tetrasubstituted alkene, that's fairly stable. The equilibrium between the secondary cyclobutyl cation and the tertiary cyclopentyl cation is really extreme. This is a much more stable cation than that. And so you'd expect the rearrangement to happen, which means we're probably not going to see a whole lot of that one, the cyclobutyl product. Really, any of these 3 are possible, even likely. And so probably under these conditions, you would see a little bit of all of these. But the major product's going to be the tetrasubstituted elimination product.